What's up, guys? Shawnthebro here, and today we are going over an episode that I am very excited about. We are going over what I like to call buffered input part 2, but really the common term would probably be input windows or buffer windows. Essentially, these are frames, windows of frames, or windows of time where you can execute an action, a series of inputs, and perform an action. So we've had a lot of episodes on buffered input and input buffering, and I know I kind of use those terms interchangeably. They are technically different, so I apologize for any confusion. Let me sort that out right now. So over the quite a few episodes of this series, we've done things like performed an action and then allowed ourselves to perform the action again by pressing the input. We've also done things to perform actions such as pressing a certain amount and certain sequence of keys or buttons on a controller to perform them. So for example, my fireball is back forward G on the keyboard, or basically back forward light attack. We also have the ability to make basically any amount of complex commands that we want work. However, what we were doing in the past was using seconds and just clearing the buffer every 0.2 seconds, basically hoping that the player would enter the command at the right time. And we also were just using time compared to frames, which most of this is you have your window, your input window, which has like 6 frames. I've seen 10 frames before. Some might even be less, like you have to do it in 4 frames or something. Basically, within 4 to 6 frames, however, I set it to be 6 here, I have to perform the inputs to perform the fireball if I want to actually get it to trigger. Before, in the past, we would have 0.2 seconds. But if I do my inputs a little slow, you can see them popping up on the left. I am doing back forward light. I did a dash in there. I was trying to do it quickly enough. You see, as I start to do it a little bit quicker, I can start to do a fireball, and now I can cue other fireballs. Now, ignore the input stack on the left side, only showing light punch. I have logic to only display the movement if we can move, which we can't move while doing an attack. I'll have to update that now that we've changed some of our logic to be able to cue moves. So performing another action while we're already in a move. So that's on me. But it's too much for this episode for how much is going to be happening. You can see I can perform these inputs. Here we go. You can see I can perform these inputs and they fire. Now, that looks like what we have. So if you're looking at this and you've been following the series, you're probably like, that doesn't look like anything special. But let's add a few print strings here, and I'll show you the difference. Let's go back into our game. I'm going to keep doing this stage because I'm actually fixing some issues with that third stage. I accidentally deleted some of the trees in it by mistake. Okay, so here is, I'm using the frame number. So you can see it's a large number. This is how many frames since it's been running, not since the match itself started. However, the frame count doesn't really matter. You can see in the top left, and it's actually very difficult to see. So what I'll do is I'll give you the output log here as well. And you can see it, how it's, look, 133,523. These are the frames. I set the game to be 60 frames per second. So you can see it should be going up at that rate. I'll show you how to do that in a little bit. And okay, so you can see the frames. Now, let's look at, I'm going to perform this input. It should give you 3 frame numbers, the numbers at which I performed each action. Okay? So you can see I performed the first input at 32, second at 37, and the last at 41. Now, if I go into the code, you can see I have the max frames between inputs set to 12 for now for ease of access. That does fall into 12 frames. Okay, so I go back to this for you. Then you can see, look at the frame numbers again. You ready? That was within 7 frames. Now, if I do it just outside of 12 frames, look at that. So it took me 17 frames to pull that off, and I did not make it. And now if we do it again, you can see I did not make that because that took me 15 frames. And now I did it in only 8 frames. And that one in 8 frames again. So you can see how if I get it within the right amount of frames, I perform the action. Now, this alone may not seem so impressive, but this is very, very important, because using this frame system will now set us up for using frames everywhere in the code. Now that our input system works off of frames, we can also make our animations only a certain number of frames and different things like that really line up, so we know which frames, which actions can be performed. So it's exceptionally useful for that, and for preparing attacks, you know, and setting up like advantages and disadvantages on block, different things like that. Okay, now you can see there is a little bit of stutter since I've changed this to be 60 frames. If we run the command stat FPS, it will show you the FPS counter, and it basically locks it to 60 frames per second. Now, it can sometimes cause a little bit of this jitter depending on our actual animations and different things like that. So don't worry about that. This will be cleaned. We have to do a lot of things in the future to actually clean this stuff up. When we're really worried about performance, especially for online and different things like that, we need to make sure that this is running as well as possible, and it's also optimized for 60 FPS. Before, I was using smooth frame rate, so it's actually running faster than the 60 FPS. Limiting it sometimes actually can hurt you like that, where it makes some things look a little bit weird. But don't worry, these are all things that can be easily fixed and adjusted in the future. The only reason I'm changing it to be 60 FPS now is because it is very important that we stick to that going forward. That way we work off 60 FPS for all of our inputs and different things like that. Not running at 60 FPS, running below it or potentially at varying speeds can be very bad in a competitive setting for a fighting game. So what I do is I go to Edit, Project Settings, and then I go to Frame. I type in Frame up at the top, or Engine General Settings, either way. So you can go here if you'd prefer. And look for the part about frame rate. So I've made the fixed frame rate 60, and then I've checked the use fixed frame rate box. The smooth frame rate is what is on by default, and it does make it look the best right now with what we've got. However, we can use fixed frame rate to figure out some things, figure out exactly what 60 FPS looks like and how the game will perform. Now, a lot of the times this will be lower than your smooth frame rate, so again, things may look a little bit worse, but we can adjust that in the future. We actually can stick to the smooth frame rate and just set some rules in place and make it look better. So we have a lot of options here. I'm specifically using the fixed frame rate just so we can test this with 60 FPS today. We'll have entire episodes dedicated to all this sort of thing as the project goes on. For now, the main thing is that this is running as we intend the game to run in the future. So once you've set that up, you can close this. And you can see I'm printing the frame, so I'm going to undo that. But I have the same logic set up for player 2. So we have a lot we can cover today. Okay, today's going to be a big one, so after that long explanation, let's get into the logic. However, I will say, if you've not watched the other episodes of the series, we are going to build on a ton of logic that we've used in the past. I try to separate these episodes as much as I can, but this one in particular has a lot of stuff that we're already using. However, if you're specifically here to see the input window, then I will be covering that in full. It's something we did not have before. We were using arbitrary timestamps, so the input window will be fully covered here. If you would like to watch other episodes of the series and catch up, I'll leave a link to the playlist in the top right corner. You can watch all the fighting game episodes. And I will also leave a link right here for the input buffer episodes specifically. All right, now to get started, let's go to our fighter template character.h. So fighter template character.h is our base character class. And what we're going to be doing today is converting our system from seconds to frames, and then also changing the way we check for inputs, special inputs, such as special attacks and commands that have multiple inputs. So before, when we press buttons, we were just checking to see if the input buffer lined up and then performing that action. Now what we want to be doing is perform inputs, add them to something called a circular buffer, and then have the action be performed. Every tick it's going to go and check and see if there's an action that's available to perform. Now the important part about this is we can then queue inputs and they will be performed at the next available frame. There's a lot of things we can do here to change it to be the way we want, so don't worry. I've done a lot of research on this, and I've tried to figure out the best way, and I think this is the best way that I'm aware of that we can do everything. We can make it as open as possible. So bear with me. We're going to have a lot of changes today, but I'll go over the entire system as a whole so we can hopefully all stay on track. First things first. In the F command structure that we have, commands are our special inputs. Commands are like quarter circle forward, quarter circle punch, different things like this. They're actions that we perform, either keys or buttons that we press in a certain amount of time to perform a special ability. So a command is that special ability, that special attack. What we need to do today is add an additional variable called max frames between inputs, or whatever you want, but I call it max frames between inputs, which means this is how many frames from the start of the command to the end of the command. And don't worry, I know that some games have it where you have like 6 frames to go from one part of the command to the next part, and then you have like 4 frames to go from that to the next. That is perfectly viable with our solution. I actually already have it mocked up, but we've got a lot going on today, so there's certain things like that I will be skipping. I want to keep bringing these up because this is perhaps the most important system that we've made to date, and I don't want you to think that I've forgotten anything or left it out. This is intended to be the final variation of this system. There's more we have to add to it, but I don't want to change it anymore. I want to continue using the input window and then add logic as needed to fit other needs. Okay, so the command needs a max frames between inputs. If you always want it to be the same, and some games have that, you don't need to put this in the command itself. You could have a variable just stored in the game mode, or it could still be in the character, where it's got a specified max frame. So it's always 6 frames you had to perform this command. All right, now in our F input info, this one's getting a little bit messy because of the fact that we were using the input name in the past, and we were also using the timestamp. We don't really need the input name or the timestamp anymore. We just need the input type in the frame. However, I'm going to leave these both in here, at least for this episode, so that I don't confuse you by just taking everything out and then saying, yep, this is what it looks like now. That would be confusing. So I'm going to show you what we had and compare it to what we have now. So timestamp was a float because it was in seconds. It was, 0.2 seconds was when this was pressed, or 55 seconds in the game this was pressed. Okay, and then input name was the specific key or button. Well, now we're using types, remember, so like instead of pressing G on the keyboard to perform fireball, we press light attack after back and forward. So input name and timestamp are basically obsolete. So remove them if you'd like, but you don't need to. You can keep them here. But for bloating purposes and for purposes of memory, we'll want to trim this down eventually. Point being, you need input type, was used, and we're now adding frame. So I made this an int64. This is because frames, the way Unreal tracks them, they're an int64 type. So it's good when you can match types. It stops conversions and it stops loss of data. All right. I'm going to skip the circular buffer for now, but it's going to be pretty much the highlight of today. So go down to where your Booleans are, or wherever you want to put this. And I had these all the way at the bottom, so they were easy to find. We need an integer cur tick, which is the current tick, so the current update. I'm assuming that there's 60 frames per second because that's what I want the game to run at. There is a way to find this out and calculate it, determine what your current FPS is. But really, in my opinion, what we should do is just start this at 0, lock the frames to 60 FPS, and every tick, every frame, update this value. If we do that, we will make sure that no matter what, we are working off a 60 FPS system for this window that we have. All right. And then for this Boolean, captured input this frame, This is a new one as well. This is what's going to be used for multi-press attacks. So if you want to press to grapple, to throw, if you want to press 2 buttons on the same frame or within a frame or 2, if you want to be able to capture that, we're going to need this. This is going to be useful anyway for today's episode, but it's going to be more useful in the future. So just make these. It's okay if they don't make sense right now. I'm going very in depth in this episode compared to a lot of the episodes because understanding this is incredibly important. All right. Now, we had this thing called the input buffer. And now I've made something called the circular input buffer. By all means, go ahead and convert your input buffer to just use this. Like, quite literally, you don't need 2 of these, okay? You could comment this out and... Excuse me. Let me make this easier. You could comment this out and just leave this as input buffer. All right. Again, I was trying not to confuse anybody, so I'm not saying... Yeah, I didn't want to, like, just remove it where you guys couldn't see it. This is what your input buffer variable should look like now. Now, there's something you have to include to get this, but let me explain something first before we get into this, because this is also complicated. The input buffer is something called a circular array. A circular array is essentially an array that has a start and an end point, and once you reach the end, it rolls over to the next point. It's a little bit more complicated than that internally. It stores an additional value at the end to know when it's at the end so that it can go back to the 0 index and all that. But that's not honestly too important for this. We're not going to be really using a circular buffer much for the fact that it's a circular buffer. I made it a circular buffer type so you know what we're using and so that you can understand what the purpose of it is. Really, you could make it an actual array circular. It's not super difficult, and I think you'll see that as we make this. But Unreal does have a circular buffer type that is a little bit optimized for buffers. So I threw it in here for now. You know, we may change it back to an array, but it's really not a problem. It's more just so that you understand what's going on. So this is your input buffer now. So make it look like this. And you'll get a few errors because you don't have this file. Make sure at the top, if you are going to go the circular buffer route, that you include container/circularbuffer.h. All right. So this is super important, mainly because a circular buffer is, as I explained earlier, it's going to keep track of our inputs. Now, think about this. Sometimes I write this up on Paint, so we might do something similar, but I think I can explain it well enough. So, before we were clearing every 0.2 seconds after pressing a button. We were clearing the input buffer. Now, you know, that's actually fine for most cases. However, when we're talking about these very specific skills in this fighting game, we want this to feel as nice as it possibly can, as professionally made. We don't want it to have a lot of bugs. We don't want to miss input. What we need to do is we need to know that no matter what frame we press something on, if we press them within the correct amount of frames, we perform that action. You know, unless there's something else that comes up that cancels it, whatever. But assuming we're just pressing inputs, we need to be able to make sure that it can get performed when the time is right. So, a circular buffer guarantees that because it goes from 0 to 59 is essentially how a 60 frame input buffer works. And because that it goes from 0 to 59, it will roll over and our inputs will still be there. So now that that's clear, let's go over what makes this input buffer important and how we have to set it up to make sure it matches what we need. So, before it was just a T array of F input info. Now what we're doing is we're using T circular buffer of F input info, but we have to define it. We have to use its constructor, essentially is what's going on here. If we don't do this part at the end, then it will cause issues because the circular buffer by default needs a size. It doesn't have a default constructor that will run. We have to pass it a parameter for it to run. That's, you know, kind of an in-depth C++ thing, but Essentially, we have to set it up. It won't set up on its own. It doesn't have a default value. So all we do is we make one of this type, okay? And then this 60 is how many items it can hold. So 60 is 0 to 59, but it holds 60 items. That's how this works. So this is very much the same as our input buffer. I'm changing it to a circular buffer again because, first of all, the name is matching what we're going to be using, and also because it is supposed to be optimized for this sort of thing that we're doing. That's what Epic claims that it is. I honestly have not run the tests, so I don't know, but worst case scenario, we just change it back to a T array. We can make a T array a circular buffer very easily. It's not a problem. All right, so I've called it circular input buffer in the code. So to not confuse anybody, I'm going to revert it and just leave it like this. It's circular input buffer, okay? So when you see circular input buffer in my code, you know it's this. I'm not using this anymore. I just wanted to point this out. So circular input buffer is my input buffer. All right, that's incredibly important, but at this point we've explained the system, and I think we're good to continue. Let's go into the CPP of the character and set the default values in the constructor if needed. Okay, so let's go down to add input to input buffer. I've moved my functions so that all the functions we need are next to each other to avoid further confusion, because again, this episode is quite complicated. So add input to input buffer is a function we already had. This is when you press the key, the blueprint picked up on the key you pressed and sent it to the code. That's good. We've added a lot of stuff in here. We're going to need our check input buffer for command using type, which has changed pretty drastically. It's the same process. So I left the stuff commented out that we don't need anymore. Determine command to use. Start command. Cool. So let's start at the very beginning. The beginning is the blueprint. When you press an action and any sort of input, we have this add to input buffer P1 and add to input buffer P2. Add to input buffer P1 is the only one that matters for most cases. It matters for player 1 on the keyboard, and it matters for any controller. All controllers are this. Since we have functionality to support keyboard mode or multiple players on one device, I have to do this to kind of hack it to say, oh, this person, even though it's assigned, the keyboard is assigned to player 1, it also has control over player 2. So if you're not familiar with the series, don't be confused by this. We are basically just using this. This is essentially a method I have to support multiple players on one keyboard, since Unreal does not support that inherently. All right, so our logic here was actually pretty simple. What we did was this. This is an any key. If we go into our project settings and look at the add to input buffer P1, this is essentially any key that our players can press that belongs to them. All these buttons, it works for both gamepad and keyboard, are buttons that only belong to player 1 on the keyboard, or buttons that, are going to be used for actions. Again, if you're on a gamepad, everyone's going to have their own gamepad, their own controller. So we need, of course, the controller support, but I also need the specific keys bound to the actions that we made earlier in the series for each player. Okay? All right. So when any key that is valid for that player is pressed, all we do is we get the key display name to figure out what key it is, and I was passing that into the input name. We switch that over to just get the type based on the key we pressed. That's what I was saying, it was unnecessary earlier. Now we've already done this, so we don't have to go over that again. But we're going to do the exact same thing with the timestamp. Before, we were getting timestamp and passing this in to the input buffer. We don't really need the timestamp anymore. Again, I'm keeping it, but the important one here now is the frame count. The frame count's the MVP. He's going to be overriding the get time seconds. So there's a node in Blueprint called get frame count. It does the same thing where it shows the total number of frames that have occurred. I believe it's since the engine has been running. In case of packages and standalones, it's since the game has been running. And I'm going to pass this into the input info frame. So the add input to input buffer takes in f input info. F input info, if you remember, got the frame variable added to it. So now we have to just update these functions to take in the frame. The frame, like the frame number, does not matter. It's the difference in frames that matter. We do have to keep track of the current frame so that we know where to store it in the circular buffer. But it's not specifically the frame, like, oh, frame 192, 68, I don't know. It's not the specific frame. It's the frame in relation to the second. So if you're on the 30th frame of that second, that's all that matters. The buffer is only going to keep the logic for so long. I mean, it's going to be overwritten. Every tick is a frame. So every frame is going to store buffer data, and you can store it for as long as you'd like. I decided to just store it for 60 because if there's 60 frames a second, storing all your inputs for 1 second seems pretty logical. It is a circular buffer, so we no longer clear it and ruin everything that we have inside of it. So we get our frame count and we pass it along to our function add input to input buffer. Alright guys, one more thing we have to do. In the base character BP, we had tick where we were doing all this stuff with remove old inputs from buffer. And we were doing that for player 1 and 2 in case it was keyboard. We don't actually need to do this anymore. We're not using the seconds anymore. We're using frames, and it is being overwritten. Every second, essentially, it gets completely overwritten with those 60 new frames. So we don't need to actually manually remove these or try and reset them based on time or anything like that. So I've just disconnected tick, but quite frankly, feel free to delete the entire thing or just remove these from it and just leave the node there on its own. So quite literally, we press a button and it calls this function in the code with all the logic that we actually want. This stuff was already here. This basically just switches your left and right depending on the direction you're facing. And here's where we get into the good stuff. Now, this was being added in the past, so I'm going to comment this out, but it should look familiar to you. Once this add input to input buffer function started, we changed our inputs, and then we added the input info to the input buffer. That's what we were doing in the past. You can see I've just commented out, so we're not doing that anymore. What we're doing here is we're going to take the current tick. Remember, the circular input buffer can hold 60 items. Every frame, we're going to add something to it. So what we're going to do is at the current tick, we are going to set that equal to the input info. As opposed to adding it to the input buffer like we were doing in the past, we take our circular input buffer at the index cur tick and set it equal to the input info that's coming into the function. All right. So the circular buffer, don't be confused. Just think of it as an array. Again, it quite literally is just an array that has other functionality, but it's just an array or a queue. It's a structure meant to hold 60 frames worth of data in terms of inputs. So if we're at frame 0, then the input at frame 0 is equal to this. So I'll show you what that looks like in a second. If not captured input this frame. Now the Boolean should be pretty self-explanatory, but essentially we're now going to be capturing input every single frame. Now the user isn't going to put in an input every single frame. In fact, a lot of the frames are going to just be no input, either standing still or they're watching the enemy, and they're not necessarily adding an input to the circular input buffer. So if they have not captured input this frame, we want to add this input. All right. However, if you press 2 buttons at the same time, on controller keyboard, doesn't matter, on the exact same frame, if 2 inputs come in, then we know that an input has already been pressed. This logic's going to run once for add input to input buffer, boom, and it's going to run again, add input to input buffer, boom. Well, this gets set to false every frame. You'll see that in a second. So if this is true, this is if not captured input this frame. We set it to true after assigning the input in the circular input buffer. So if this is still true when this comes around, that means it goes into this else, which means multiple inputs were performed on the same frame. All right. So that's for the future. We're not going to concern ourselves with that now because that's a lot. However, I wanted to point that out why it's useful. The other reason why it's useful is that a lot of times the player will not be pressing an input, whether they're standing still or they're just watching their opponent, whatever's going on, they might not have an input in there, and that's okay. The circular input buffer holds essentially the evaluated input data for every frame. So if the user's not pressing anything, it's still going to add data. It's going to say, yeah, they haven't pressed anything. Okay? That'll make more sense when we get to in a second. So this is what add input to input buffer looks like. It's okay if this is still confusing. It took me a very long time to wrap my head around the system, which is why I'm trying to take so much time and go in depth with this. All right. So let's go to the tick now, because I think the tick is actually more important in this case to help understand the system. Let's see what happens every single update. Tick fires every frame. That comment that says called every frame right here, that is something that Epic puts in. I didn't even put that in. So that's proof it fires every frame. So if it fires every frame, guess what we can do? We can keep track of not only what frame it is, but we can determine if an input was pressed that frame and then determine the logic that we want to use. Now this works out really, really well because this is tick on the character class in the code. The blueprint character, base character BP, actually ticks first. The object that is actually in the game will tick first, and then the parent class is tick, because the blueprint is a child of this class, which means its tick functionality goes first, and it calls super tick. All right? So it's going to go through its tick function, and it's going to call this tick function, and then we're going to do the logic in that order. I'll show you an example of that in a little bit, because I think it's important to know that difference. But that's super important because it means that we will get our update for the frame before the frame updates here. So when we press an input, we know what frame we're on, and then we can update the frame afterward. Okay? That's very important. So we have logic here to just update this variable. This is very, very simple. This is a cur tick. This is our integer that keeps track of what frame we're on, assuming we're running at 60 frames per second. All I do is I check if cur tick is less than 59. Remember, a circular buffer that has 60 really goes from 0 to 59. So if it's less than 59, it can still be added to. If it's equal to 59 or greater, we want to set it back to 0 instead. And this is why it's circular. And this is why you can do it with a regular array, too. It doesn't have to use the circular buffer like we're using. It could be a regular array that's just circular. It's very simple, actually. It essentially means that once we reach the maximum value in the array, we just restart back at 0. Okay? Now, we have this thing that says, if not captured, input this frame. And we did this check earlier in the add input to input buffer, but this isn't tick. This will be after add input to input buffer. Okay? It's actually called after because add input to input buffer will be called on the child before the parent gets called for the tick. So, if this is false, that we have not captured input on the frame, then that means we have to add a none input. There's a few ways you could do this. What I do is I make a none input and add it. We might want to actually have one made already and just keep adding it. I think that's probably less expensive than adding more to it over and over again. I'll have to look into that. But either way, it's going to be a very small change. We could basically move it to, the top of the file or some other spot, and we'll just access it and add it every time as opposed to creating a new one. It probably is better. But regardless, that's something that's easily changed. Won't change our system at all. So, if we have not captured input this frame, remember, we still want to add to the circular input buffer. The circular input buffer is going to be used to check every frame. It's going to go through every frame within the last set of frames and see if we perform the action. So, if no input was pressed, we have to make sure that we still check to see, check every frame. We have to check to see if they press something or not. Because otherwise, you press an input, you don't press anything. 60 frames go by, then you press the next input. If that's the next thing that got added to the array, then the sequence the input window would just say, oh yeah, you press these two inputs back to back. We don't want that. Every frame needs to be checked for input. So if the input was none, we need to have none in there. That's how we know how many frames have passed and how many frames the user took to press inputs. So if there was no captured input this frame, that means the user didn't press anything, so I'm adding a none input. So quite literally, I create a new f input info and I fill out the data. I'm actually going to set this to 0, but it doesn't matter. The important parts are set the input type to none. I did actually make an enum of enone when I originally made this enum. If you didn't, you can always add one now. So I set to none. Assuming we're still using the name or timestamp, which I will not be, but if you want to for whatever reason, I put it to none and 0.0. The frame I set to something called gFrame counter. This is essentially the exact same thing as getFrame count here. So it just grabs the current frame. And then I set was used to false. And yes, I add it to the input buffer. That's if we were still using the input buffer, but we're not. So we can comment that out. But the circular input buffer at the current tick has to be equal to this none input. No input was provided by the user on that frame. For this character, notice I'm doing this in the character tick. Each character will have their own. Else, if captured input this frame, that means we already set the circular input buffer already has a value for this frame. We don't need to set anything. So else, we just set captured input this frame back to false for the next frame. Okay. And then we're calling determine command to use, which we were doing in the past, but it's still here. It did not go anywhere. So don't remove it, just move down a little bit. You do want to do these things above it. Make sure you keep that order correct. All right. Now this next part is going to be very difficult to understand. So let's take a quick second and let's cover everything that we just went over in the game. All right, I have some logs in here. You don't need this log. This is just for example, but if you want to add it in, go for it. What I've done is I've added a log and I've printed out the tick function and the frame. Okay, this way you can see the order of events. This is the code tick, the one that says tick function, frame, and then with a number. %D stands for decimal, which you can use an integer and 64. You can technically use other types that can be converted to it, but either way, not really important. That basically it prints out an integer value. And we're printing out the gFrame counter, so the frame number. All right, that's what we're printing to the log. Now let's go to Unreal. And let's go to our string here. Now let's watch the order of events. The log is going to get spammed like nobody's business, but it doesn't matter. This is to prove a point and to kind of show what's going on here. Okay, so now we're here in the game. I'm going to move this window. You can see that the tick function is running 60 frames per second, and you can see it updating fine. Now I have the logic in there to print out the frame number. It's in the character BP here. All right. It prints out the frame number when we press an input. So let's press an input and let's see what happens first. Okay. Pause. All right. Now let's look at this frame that we have. You can see the order they're printing in, right? They're printing like this. Now, you can see that there's 2 of each number. This is normal. This is printing both for player 1 and player 2. All right, so this is very normal. It should be printing 2 for each frame, 1 for each character. But you can see the order. The top is the newest, top is the oldest, newest is at the bottom. So as we go down the log, there are newer entries. Okay, so the oldest entry for 3,723, frame 3,723, is the one from the blueprint, which means the blueprint logic for me pressing the input captured the frame before the code tick captured the frame. This is important because we know that when we press a button or we press a key, that this Boolean will be correct because add input to input buffer already fired before captured input this frame did. And because of that, we know that this will function correctly. And if you really wanted to check, it's very simple. You can also add a log in here with the same stuff. All right, so if we do this one more time, and now with our new log in place, I can wait for this to go away, press an input, pause. All right, now let's go look. I think it was 949 is what it said. All right, so take a look at this. We have add input to input buffer frame 949. We have the blueprint. We have the tick function. All right, so there you go. So now we know that the add input to input buffer is going to be before the tick function. End of story. And that is excellent to know. Knowing that means that whenever we perform an action on that frame, before it gets the tick, it will know what frame we're on. So pretty simple in terms of that logic. It can definitely be very confusing, but I wanted to print this out. So add input to input buffer. There's the blueprint. Here's the tick function. Then it goes through and says, oh, using command light attack. That's a different log. But then here's the tick function for the other player. Character, I should say, but either way. All right. Now that we know that, we can get rid of some of these logs if we want. We'll wait till after because they're not hurting anything. But that's the flow of things. So add the input buffer, then the tick. So this is also important because we want to determine what move we have to use. If we want to do that, we have to call this check input buffer for command using type. Now we had this function in the past. It has changed greatly since then. So it's still called at the end of add input to input buffer. If we scroll down, here is what it looks like. This is actually the whole thing. It technically ends after this, like that. Like that. So that it actually ends after this. But I have these comments in here that I still put inside the function. This is the old logic that we had for it. So I won't go over the old logic, but as you can see here, this is the original method for buffered input or input buffers. Utilizing the new system we have that uses frames instead of seconds makes this block of code obsolete, and it's true. We no longer need everything we're doing here with the new way that we're handling things, and we're handling it frame by frame. This way is more efficient, and also it pretty much only works if we do it off frames and not seconds, so that's why we didn't start with that. But don't worry, it's basically a lot of it is the exact same. It's slightly modified, but it's a lot of the logic comes from the exact same place. And I'll be covering it all right now, so don't worry. All right, so this is basically all the logic you need outside of two closed brackets at the end here. So I'm going to keep the screen like right here. I don't think I can get it to a better spot. There we go, actually. That's perfect. So we can look at it like this. This is where we'll keep it, and I'll cover this. So we still have correct sequence counter, but correct sequence counter is actually going to work a little bit differently now. So I kept it the same name because I wanted to I wanted to confuse you guys as little as possible. But really what correct sequence counter is now is like remaining matching input counter. Because since it's a circular buffer, it's impossible for us to know, or at least not without saving it out and manually doing a lot of extra work, it's impossible for us to know what frames the inputs were pressed on without looping through them. But understand, we don't care what's in the circular input buffer at all the spots. We just want to know if the correct inputs in the correct sequence are within the specified number of frames. Every index in the circular input buffer represents one frame worth of input. So if they're that many spaces apart, you know they're within the proper amount of inputs. So let's think about it this way. Correct sequence counter, like I said, it's still basic. It does the same thing, but we're going the opposite direction. We're not counting up to the correct sequence. We're starting at how many inputs we need and subtracting every time we find one. All right, this last successful input frame is unnecessary for right now. This is how you would cover if you wanted, like, these two inputs can be done within 6 frames, but the next input in that sequence has to be done within only additional 4 frames after that second input. If you want that sort of logic, then we can do it this way. I'm not covering that today because of how long this is already going to be. But just to kind of get you thinking about it, and maybe you want to put it in there as a reminder for what it's used for. All right. So you should notice, if you've been following the series, this is very similar. We're looping through the commands. We're looping through. We have auto current command and character commands, which means for each command in our command list. Our command lists are determined per character, so however many commands you give to the character, it's going to loop through each of these. Then we have our correct sequence counter, and we were setting it back to 0. You know, you want to set it to 0 because, oh, you missed a matched input, so we're resetting it. This time, we're going to set it to the length of the current command. So if the current command is backward, forward, light attack, like my fireball, we actually are going to set it to the length of that. So current sequence counter equals the current command dot input types dot num. Input types is what holds the backward, forward, light attack. And dot num -1. Dot num returns the actual number of elements. So of course, if you're doing that, then if you have backward, forward, light attack, it would return 3. But we're going to use correct sequence counter inside of the input types array. So if you tried to array index will start at 0, so it really has indices 0, 1, and 2 for 3 elements. If you try and access element 3, it will crash. So current command.inputtypes.num -1. All right, so I've commented out the next set of lines because it's not necessary for now. This is also important for different things we use down the line, but it's not really important for right now. This could be used, again, if you want to do special types of inputs. To stop confusion, I've just commented them out. I still want them in there because I have a plan for them, but I didn't want to confuse you guys, so sorry about that. But it's the same stuff, so we have the correct sequence counter, and we're just going to skip this next part. I mean, you can add it in if you want. It doesn't hurt anything, but we don't need to cover it now, so to make this episode easier, I'm going to skip it. Okay, the next important part after setting the correct sequence counter to the default value is we have to loop through every frame, but we only want to loop through the frames that we know are within the certain amount, right? So if we only have, if a sequence must be performed within 6 frames, we don't want to check the whole circular buffer. We only want to check the past 6 frames to see if they have the proper input. So if you remember, we added to the F command max frames between inputs. I made it 12 because it was a little bit easier for me to perform them, but you can make it 6 or whatever you want. It's just going to take the frame that we're on, make sure that it's less than that value, and then we'll search through this circular buffer. We only want to check the last 12 frames, so that cuts down a lot on what we were checking before in the input buffer. We were checking through every input buffer thing. So if you added 500 things within 0.2 seconds, it would have to look through all those. Now, it will only ever check 12 frames, so it never gets more complex as far as checking these values in here, which is insanely good for performance in comparison to what we had. Now, what we're doing is we're going to take the frame, I'm calling this integer frame data to check. And really, I guess let's actually change this here. Let's just call this frame to check. Okay, I think frame data is a little confusing in this sense. So let's call this frame to check. Integer frame to check equals this thing, right? This equation, which looks confusing at first, but I think it'll make sense. I might have to write it down. We have our current tick, which we know only goes from 0 to 59, or essentially 60 inputs. We know there's 60 frames a second. So current tick is between 0 and 59. We take the tick that we're on and subtract the frame. Okay. The frame is just from 0 to 12 in this case, or 0 to 6 in your case, whatever the difference is. The reason we do that is because we only want to check that number of frames. So if we're at frame, say at frame 30, that's the current tick. We subtract the frame. The first time around, it won't change anything. It'll be frame 30. So let's write this down in Paint real quick. I think it's important enough. All right, so I have Paint here. I don't want to make it too big, so I'm going to leave it pretty small so you can see the logic here. But let's look at this. This frame to check really is key here. We have to make sure we're doing this correctly. So this value is going to determine what frame in the circular buffer, circular input buffer array that we actually check. And to do that, we have this integer called frame to check. So I'm bad at I'm bad at Paint, but let's say frame to check equals, so we have the current frame, so we'll say CF is current frame. So frame equals current frame. It's current tick, which is accurate, but let's refer to everything as frame so that we understand what exactly is going on here. This frame in the for loop is the frame offset, essentially, minus frame offset faux. All right, so the frame to check equals the current frame minus the frame offset plus the circular input buffer dot capacity. So current input buffer dot capacity. Capacity is the way you do .num on a T array. It's the same thing for a circular input buffer, so don't be confused by that. This just returns the count, which is 60. You could also hard code 60, but it's usually better not to do that in case you want to change the circular input buffer in the future. If it's like you change it to 75, you'd have to change it here too if you didn't use capacity. But let's just say cap. C-A-P. Ooh. Cap. All right. And then all this is modded, which I don't even know how I'm going to do this symbol. Modded by cap. Okay, well, this is really ugly, but really this is what I wanted to point out, since the names can be a little bit weird and this equation is a little intimidating at first. So this is the frame to check. Let's simplify this. Let's put it in real numbers here so we understand what's going on. So frame equals, let's make it simple. Let's say we are on frame 40 for that second. It's 60 frames per second. We're on frame 40 of this second. Remember, we are in the check input buffer for command using type. That's the function we're in. This gets called when we press an input. So say we pressed an input on frame 40. And what we have to do is minus by the frame offset. All right. That's important as well, because the frame offset determines how, what values we should change where we're looking by, okay? So frame offset is 0 to start. So let's start at the beginning. Minus 0 plus 60 and then mod 60. Not BO, but 60. Close enough. And now this value is pretty simple to figure out. If you don't know modulus, basically it returns the remainder for you. So if we finalize this, the frame that we're going to check, 40 minus 0 is 40, plus 60 is 100. 100 divided by 60 is 40. So with the frame offset of 0, it becomes very simple. We check frame 40. All right. Now let's put that into, let's figure out what that means. So remember I said this function gets called when you add an input to the input buffer, which we previously determined happens before the tick even goes off. So once you press an input, it gets added to the input buffer on the same frame. Okay, so at frame 40, say we used backward. Let's keep using the fireball example to not make things more confusing. Fireball is backward, forward, light attack right now. So frame 40 is when we press the key. Let's say it's when we pressed backward, when we pressed the first input. It's going to check the circular input buffer at frame 40 and grab the input type and set it equal to this local type variable. So this will be backward. We check if it's equal to the current command input type at the current sequence counter. Now, the current sequence counter, we're going backward through the circular buffer. So the current sequence counter is not 0 anymore. It is equal to the input types.num So current sequence counter of this input type, it's looking for the maximum index. It's looking for index 2 in this case. It's looking for the light attack. So this is going to be false, flat out. So this is going to not go into this if statement. It's going to go into this else if. We're going to check if the type is none. And then if it's not none, we are going to reset it back to the maximum value. Line 779 here and line 798 are the exact same. We're just resetting the current correct sequence counter. Instead of setting it to 0, we set it to the max value. Why we don't set it to the max value if the type is none is because it doesn't mean that the user pressed an incorrect input. It means that they didn't press any input. So, if you're a human being, it's kind of hard to press an input every single frame. That is important. But we do need to make sure that they don't press the wrong input. If I press backward light attack, I should not perform fireball. So if I find a type at that frame that is not equal to something that I care about, I need to reset it. We're not on the road to the correct sequence right now. Now let's look at this again. Let's change the parameter a bit. Say at frame 40, we'll keep this so I don't have to rewrite this, but say at frame 40, I press light attack. Now previously I pressed backward, forward. So let's say within 6 frames, I pressed backward, forward, light attack. The backward and the forward are going to fail out and it's not going to perform any action. But when I press light attack, this function still gets called. The backward, forward are still in the circular buffer. They have not been replaced yet because it hasn't been 60 frames. It's only been 6 frames, so I know they're still in the buffer, and we can still check them. So let's try this again with the new value. So we loop through, eventually we get to the command fireball. And we loop through the max frames, so say it's 6 in this case. We say, okay, we take the cur tick, we do the logic, we get frame 40, check frame 40. At circular input buffer, frame 40, the input type is light attack. So the input type is light attack, which means this if statement evaluates the true. Light attack is equal to the current input type at the last index 2, which is light attack, which means we subtract from the correct sequence counter. We're going backward. Okay, now we already have 1 right. We got to check the next index. At that point, we check if the correct sequence counter is equal to -1. And if it is, we're going to add the command. It's not yet. So the correct sequence counter has to be equal to -1. Instead of equaling the input type .num like we were in the past, what we're doing is we're checking if it's equal to -1. It's the same thing. We're just subtracting instead of adding because we need to check the circular input buffer backward. We need to check it in reverse. All right. Now, I'm not going to rewrite all this because this will make it a little bit confusing, but let's change this value out. So this loop is going to end. It's going to go back to this loop, and frame is going to be updated to 1. Okay, let's make this a 1. Oh, not the tool I had. That's a 1. So then this is not 40. This is going to be, we have to do the math again. So 39 plus 60 is 99. And mod 60 is 39. So that it's simple enough to figure out. Really, it's going to be, it'll be pretty simple most times. The reason that we actually do this is because if it goes above a certain value or below a certain value, like for example, if you're on frame 0 and you're subtracting like -6 or something, so say you did this on frame 0 and you subtracted, the current frame that it was going on was -6, the frame offset, or 6. So 0 minus 6 would be -6. You have to make that positive, otherwise this mod won't actually work. Since it's a circular buffer, we need to make sure that we support every number in it because it could fall on any index. It could actually fall between like 58 and 0 and 2. You know what I mean? So this plus 60 is basically a safeguard to make sure that it's positive. And then we mod by 60 because we basically take out the 60 that we just added. So the math behind this is very simple. It looks confusing when you first look at it, but these are essentially just safety checks to make sure that we're always checking the right value. But the frame to check is now 39. Well, 39 So let's add a little. Let's add a little bit more here. Okay, so let's say frame 37. No, let's say frame 36. Wow. You'd think you'd never asked me to draw a 6 before. Say frame 36 is when we press backward. We press forward at frame... Oof. Okay, that's forward. And we press that at frame 38. And 60, or sorry, excuse me, frame 40, we press light attack. So L. All right, so left, forward, light attack. These are the frames we pressed them on. So we just did the one for 40, and we found out that it did match the input, and it was light attack. Now, frame 39. Frame 39, we did not press an input. So imagine these frames I did not mention. Remember what happens to them. 37 and 39 are none. None. Okay, frame 37 and 39 are none. That's a comma. So, but we don't want to reset the correct sequence counter. Think about it. Just because we missed a frame, even though we're still within the allotted amount of frames, 6 frames to perform the sequence, we can't reset the buffer. That doesn't make any sense. So only if the type is not none, type not equal to none, do we reset it. So we see that, we get in here. I'm trying to keep this up for you guys so you can see it, but we get in here and we see that the input type here evaluates to none. None is not equal to the input type that we need to continue on with the sequence, so we don't subtract from correct sequence counter. But it does fall into the else if that it is equal to none, so it doesn't get reset either. So basically nothing happens. We go to the next iteration of the for loop, the frame offset changes. So it'll be 2 now, so you can imagine what happens based off what I told you earlier. This becomes 2. Really, I should just do this. This is faster. And this becomes 2. And this becomes 38. All right, and then 38 we know is forward. So type is forward. Type equals current command.input types correct sequence counter. Correct sequence counter was 2 initially, 0, 1, 2, and we subtracted 1 from it when we found light attack. So let's subtract another one, because guess what? We found that at frame 38, it was forward. Current command input types correct sequence counter. So current command is fireball. Left, forward, light attack. These commands right here. And index 1, or the second thing in current command, is forward. Frame 38 is forward, which means they match. We subtract 1 from correct sequence counter. Correct sequence counter is now 0. It means we need 1 final input to be valid, to perform the action. So it's not equal to -1. We go to the next loop of the for loop. It's none. Frame 37 is none, as I've listed here. So it basically skips it. Then we go to the last one with the frame offset. Oops, I almost did that. So we skip 3. 3 was none because it would have been 37. And then we go to the next iteration of the for loop, and it's 4. So we get 36 as the remainder. And since we're getting 36, we check 36. There was a backward in the circular input buffer for backward. Since this is the case, type equals current command index 0. Index 0 of current command is backward because the command goes backward, forward, light attack. And because of that, correct sequence counter gets subtracted from. We decrement it again, minus, minus. Now, correct sequence counter equals -1. It gets to this if statement. This is true. We have found all the inputs that we need within the given number of frames that we said, which was 6 in this case. For me, it's actually 12, but in this example, we use 6. So we found the correct number of sequences, or excuse me, the correct number of inputs in the correct order, in the correct number of frames. That means we've done a valid input. So move buffer.add current command. Now we already had move buffer.add. It's something we've done in the other episodes. Move buffer is just it basically is going to help us determine our priority order. So we need to add this current command, but it doesn't mean that we've done the input yet. it means, okay, we did backward, forward, light attack, sure. But light attack would also fall into this. We have light attack in our move list. So light attack would also fall under one of the commands that we could use. We arbitrarily set a priority order, which is how fighting games do it. Some moves just have priority over others. And because of that, then we know that we want to use Fireball. But we add it to move buffer, the current command. So Fireball and light attack are in here. At this point, if you haven't changed anything with your other functions, you're actually pretty much done. But I'm going to cover it again just to show you very quickly. We're going to make sure that we have moves. So determine command to use gets called every tick. Remember that add input to input buffer gets called before tick, which means check input for input buffer using type. The function we just wrote gets called before the tick as well. And because it gets called before tick, we know what moves are in the move buffer. So we call determine command to use in tick. And then in this function, we check and make sure that there's more than 0 things in the buffer before we continue any longer. If there are more than 0 things, if there's at least one thing, then we set the move to use to be the default value. And if there's more values in it than that, we check against this. And we make sure that the move buffer is valid. And we check to make sure that the move at this index is, I actually just do it based off of complexity, so whatever has the most inputs. But in all reality, we'll probably give them an actual priority order and just check against that. But for now, this is fine. We see that we have light attack and fireball is more complex because it has 3 inputs. Thus, that is the move we want to use. So then I call start command. Start command finds the command out of, based off the name I gave it and sets the correct value to true for that character. The anim BP will then play that animation. So that's the order of everything. I know it is very complex on how all that works. But that's how this new system works. This is the old system. All the commented stuff that you see throughout the code is the old stuff, or stuff that's not being used at the moment. It might be used in the future. And there you go. So now at this point, we have inputs that we can use. And these inputs that we have can now be used and checked within a specific number of frames. Also, now that we have the system in place, we can convert everything else we have where we were using seconds to frames. We now know the current tick, and we kind of know how tick works within the function and within the code and within the blueprint, so we can specifically say for this number of frames. We can say, we have to delay for this number of frames. So instead of using a timer to do that, we actually just increment using the number of frames until it reaches it and we reset the state. This will make our lives so much easier, and it will go off of systems that you're more familiar with, frame systems, as opposed to seconds. So I'll just give you one final demo before we go. So you can see the blue text at the top left is printing the frame. The output log is going to be a mess because it's printing every frame, so it won't be helpful, but you can watch it if you want. Might be fun. And okay, so I press left. You can see how fast the frames are going. So if I do this slowly, I just do light attack because I didn't do it within the number of frames to perform fireball. But if I step it up a bit, then I can perform the action. And I can also queue these since it's a circular buffer. You can see I can keep using them. Now, to an extent, you may not want to do this. A lot of times you want to make sure that they can only do it if the move is either so far along or different things like that. All right, so I accidentally defeated my opponent before I could make my point, so I restarted. But if I use Fireball and then I use it again really early, I can still perform it on the next, as soon as he's available, which it comes down to when the frames are used and different things like that. However, we are going to want to specify how far out the move can be buffered, which is something we haven't covered yet, so we will need to do that. But otherwise, I think it's a pretty solid system. Not really had any issues with it. For me, like 12 frames is very difficult to actually perform, but it is very possible. You can see I can also dash by pressing 2 inputs. I have 12 frames, so if I press them too far apart, then guess what? I don't dash. If I press them close enough together, I dash. I have some other commands in here as well, but quite frankly, I don't remember all of them off the top of my head. So there you go. But you can now perform commands based on a specific number of frames as opposed to time. And since it's in a circular buffer, it should pretty much always be accurate. There is technically an edge case that could screw it up, but I'm going to handle that when we get into the charge attacks, because it only really happens if you're charging attacks, which we are going to cover, but it's completely separate. It's additional logic that we need, so it's not really an issue that you should run into now. And that's it, guys. So we'll cover more about this as time goes on, as you can expect, but that is the input window episode. So should pretty much clear up any issues that you have with that sort of thing. And player 2 can also do it too. So player 2 is not left out. I can dash. If I do it within the, let's let the thing clear. There we go. So if I tap them too far apart, I don't dash. If I tap them close together, I dash. And I can do the same with Fireball. So if I do, oops. Oh, I forgot we were in overtime, so I beat the opponent. 1 second.
Fight.
Alright, so if I, there we go, Fireball. And there you go. You can see I can do it within a certain number of frames. That there are still a few things we have to cover, like I said, for other features, other things we want to add with it, but that should be the actual system that we use in the end. It'll be tightening up on that and making it better, adding more things, but not changing the actual input window, because I'm very satisfied with that. So there you go, guys. You can see everything that we got, and yeah. I do want to add a quick bug fix to something I created when we went over complex hitboxes that I did not consider, so that's on me. But if you would like to check it out, if you go into your hitbox actor BP and your default projectile. So first of all, default projectile, I had logic for collision when we started the series as opposed to attaching a hitbox to it, and we determined that was bad. But I actually just made another overlap and never disconnected this. So you can definitely disconnect this. You can actually delete this logic now in the default projectile. You don't need it. Okay, so that was on me. I'm sorry that I did not delete that. But that's unrelated. It doesn't really cause another issue in this case, but it's just something that we don't need to have it there. It's kind of ugly and a little bit confusing. However, in the actual hitbox actor BP that gets attached to the projectile, we do have something to determine if the component begins overlap and is type projectile. So if it's a projectile type, then we were doing other logic to make sure that we weren't colliding with ourselves and certain other objects. We do need this branch if the cast fails to change this up a little bit, because we made something called complex hurt boxes, which were more specific hurt boxes than the plain square ones. If you decide to follow that tutorial, even if you're not using them, if you're using the big hurt box currently, they're still technically there on your mesh, so there is something we want to do to make sure it doesn't collide with that, and I apologize I didn't catch that. But basically, in the on-component begin overlap, we grab the other component and get the owner of it, and then we check and make sure it's not equal to the owner of the hitbox here. This is the same thing we do above, but we were grabbing the hurtbox actor BP that is attached to our character, getting the owner and casting it to the fighter template character. This time, it could be any of the hurt boxes that are static mesh components. So instead of other actor, that won't work. We need the other component. We need to get the owner of it. Make sure it's not equal to the owner of this hitbox. If it's not, meaning that the branch is true, then we cast the fighter template character and call it take damage. We still want to skip all the logic here and still reconnect at the is valid part, but I wanted to let you guys know that. There is an issue where we made, for other things, like if you want it to explode on certain things that aren't these hurt boxes, then of course we have to do more logic. But the only bug that was here, that wasn't a bug, that's just something we didn't implement yet, but the bug was here. So that was the very quick overview, but I did want to put it in. I don't like to leave bugs unmentioned, so I apologize that I missed that originally. But if you are using the complex hurtbox system with projectiles, make sure that you do take note of that. Or make your static mesh components that you added, make sure you do logic to actually use them as opposed to just casting the hurtbox actor like I was doing and missing that and having that cast fail. Anyway, guys, that's all I got for you. So thank you so much for watching. If you enjoyed, please subscribe. It does more for the channel than anything else you can do. I just really appreciate it, and it lets me know I'm doing a good job. I do work hard on these, so I hope you enjoy. I want to give a huge shout out to my Patreon membership and YouTube membership subscribers and supporters. Thank you guys so much. It really means the world to me. It helps me keep working on these, so I really appreciate it. Thank you. Also, if you need any help with this episode, I know it was very complex, or any of my other episodes, feel free to join the Discord community. I'd be happy to help you out. Alright guys, that's all I got for you today, so thank you so much for watching. I am Shawnthebro, and I will see you in the next one. Goodbye guys.